So in this video, I am going to attempt to weld up my first aluminum part that is going to be functional and put into use on my Chevelle Turbo LS build. So what we're going to do today is weld a pipe onto the timing cover to drain oil from the turbo. Okay, now I bought the Holley 303-2 or whatever pan it was, and it has bungs, but they're too close to the frame and I can't get a fitting in there, so that's not going to work out. So that's why I have to resort to going into the timing cover. So about a month and a half ago or so, I put out a video where I got the Prime Weld TIG 225. I unboxed it, set it all up, and laid down a few practice welds in this video here. So you can check that out, and I'll also put a link to Prime Weld's website. It's a great machine. I've been using it a bunch, just practicing. However, now it's time to actually put that work into an actual part. Okay, so let's talk about the turbo drain real quick. So there it is right here, hooked up to the turbo, and now I need to lead it somewhere back to the oil pan, right? So this Holley pan comes with a bung right over there. I don't know if you can see it, somewhere back here, okay, on each side. Well, it's too close to the frame, okay, and I spent the whole day, lifted the motor up, tried to get a 90 NPT to AN, and it's just not gonna work, okay? And then the AC compressor's in the way to get a nice pitch to the drain. You know, it'd be too horizontal, so that's not gonna work. So we have no choice but go to the timing cover. And what I want to do here is come in right here at an angle and sneak between the AC compressor and the harmonic balancer and this tensioner. So we're going to try to drain it right there. So here's a view from above. We're going to come down the drain, which is right here. We're going to go down and sneak right in between these two belts, right in here. Okay, so what we have here is a bung. I bought these from Monkey Fab, and it came with a lip on here, so it should go into a hole. Well, I'm butting up against this, so what I did is I sanded this down. So here's the tube. It's 1-inch OD, 1/8-inch wall, and this is a 35-degree cut, and that's going to be up against the timing cover, and then this bung on here. What I did is I hit this with Scotch-Brite and acetone, and I felt it wasn't clean enough, so I went ahead and vapor blasted it, and then I hit it with acetone again. So these parts are extremely clean. And what we're going to do is just try to put a nice tack on there for now. Alright, so I got a nice tack on there. I spent way too much adding heat. I should have went in quicker, but in any case, it's tacked. I was afraid of moving it, and this took several attempts, so at least I got the freaking thing tacked. Alright, so now it's tacked, and it's just a matter of not screwing this up. Alright, so I got a little bit of practice, and do I feel ready? Nope, but hey, let's just do it. All right, not bad, not bad. A little bit of a booger there. Still not bad, I'll take it. good. It's really hard with these round pieces, man. Okay, halfway done. Not much of a crater there, so... Dude. I'm so happy. I was so freaking nervous during this actual piece because it counted when I was practicing. Not so nervous, but man, when you get a real deal part that you could screw up, it's a little nerve-wracking for sure. Especially on camera. Alright, so the part's cooled down. Let's get a good look at this. Is this going on Instagram? No. Is it an Insta Weld? Nope. It looks kind of terrible actually, but man, this is difficult, man. Going around pipe, especially only an inch in diameter, you can only do like 3 or 4 beads, and then you got to stop, and then you got to rotate it and do it all over again. So it's tough, man. And just to give you an idea, I was practicing, and look at this. First I started here, and I'm like, what the hell is going on? And what turned out is I purchased some new lenses. I went with a stubby gas lens, just because why not? And I had the flow way too high, and that causes turbulence, and crap, this black crap comes to the top. So I couldn't figure out what the hell was going on, and I was totally screwing this up. And another thing I was doing is, you know, I have it set to 125 amps. Well, I was only going a third of the way on the pedal to clean, you know, get the area clean before I hit it with heat. Well, I spent way too much time on that. Then I went to half, and it didn't create the puddle. So I'm just adding heat, and it's not good. You definitely want to spend a little bit of time and clean, but then you want to hammer the pedal a little bit to, like, you know, 60-70% and get a puddle formed, and then you go. So it was just technique. I was screwing it way up. And then over here you can see I finally, I think, fixed my gas, and now you can see these shiny welds. You have good cleaning action on either side. And then finally, you know, when I got to this point, I'm like, all right, I can get a weld down to where it's functional. It doesn't look pretty, but you know what? Screw it. You know? So anyway, and then here, check this out. This is me going, what the hell is going on? And then I just hammered the pedal, and I was pissed, you know. I just melted a goddamn hole in this because I was getting so frustrated, man. But anyway, I will take this, man. This is my first functional part that I will be using, and that's the weld. I'll take it, man. If I want to get crazy, I can grind that down. I can polish this or whatever. But now, welding this on the timing cover is going to be a whole nother story, man. That is going to be tough. So I'll pull the timing cover off, drill a hole in it, and then we'll get back in here and see if we can tackle that. I'm kind of nervous about that joint. I went ahead and drilled a 1/2-inch hole here. It needs to be much larger. However, what I'll do is weld this guy on, and then I'll, after it's welded, I'll use a die grinder from the backside and open it up to what is needed. I also have a scribe line here and here, so now the goal is just to give it a tack and then fit it up in the engine and make sure we have proper clearances. So let me set this up, and we'll try to lay a tack down. All right, it's tacked. Woo! Okay, so I got one tack right there. I don't know what it is working on the real deal parts versus scrap is I get really nervous still. And I've had a lot of coffee this morning, so that doesn't help. So it's nerve-wracking, man. I don't want to screw this up, and you know, this is not an easy joint, okay? So there's one tack right there, and then I got a much smaller one there. And there's the other tack. It's much smaller. But in any case, I'm going to let this cool, and then we will throw it on the car and see how it looks. All right, so there it is. You know, it's obviously tacked up still, and it just clears the AC bracket by, I don't know, a 16th of an inch or so. So what I plan on doing is just grinding it a little bit to give it a little more clearance. It's not going to need much because obviously the timing cover can float around a little bit to center it up. It's not centered up right now, and there's no seal and there's no harmonic balancer bolt, but anyway, you can see it clears both the belts and the tensioner. So here's another shot. You can see right there it clears it all, and it's kind of long. I don't know if I should be concerned about, you know, someone stepping on it and cracking everything. And another thing is the 45-degree fitting here will work, but maybe I'll try to get a 60-degree and have it kind of, you know, bend in more. But again, that's a small detail. The drain's right over here, and I'm waiting for fittings on that. But yeah, this is gonna work out great. So now it's just a matter of welding it all up. But first, I'm gonna practice a whole bunch on some pipe scrap things here so I can get a feel of what I need to do. Switch the cup out to standard number 5 because the stubby wouldn't get in there. So, this is going to be difficult, man. Dip my tungsten. Alright guys, I'm going to quit while I'm ahead. It's welded, but oh my god, it was difficult for me. But at least I didn't blow through it. I didn't melt away the edge. I just had contamination. I dipped my tungsten and so forth. And, you know, it's just a tricky joint. You know, it's not easy. That's for sure. But it's on there. No one's going to see it. I'm going to vapor blast it. I could die grind it. Whatever. It's done. And I feel great about it. I don't care how it looks. So let me die grind the back. I'll vapor blast it. And then I'll show you what it looks like once it's done. All right. So here's the final turbo oil drain. So I got a 45-degree. Well, first off, let me back up. I had to clock it such that the feed and oil drain is not at 12 o'clock. It's more like 11 o'clock or like 10 or 15 degrees from straight vertical. So that's not ideal. You want it straight up and down. But I had some interference issues. All right, so I have a 45-degree fitting off the turbo. The line comes down, it's -10, and then it goes to a 60-degree fitting, which worked out nice. And there's a good amount of clearance here between the radiator hose. So that's it. I think it turned out nice. I mean, that pipe is a little long. Some people were concerned about that when I posted this on a welding forum. But yeah, you know, that weld does look crappy, but you know what? It's going to work. And if it fails, I'll have to redo it, and I'll do a better job next time, hopefully. Okay, I might as well talk about some of the settings that we used for this video. So first off, I'm going to leave the machine off because the fans are noisy and it's going to screw up the audio. Okay, so the only thing you would see is a readout here for the amps, and I will tell you what that was. Okay, so we're going TIG and AC. So both these rockers are flipped up. Frequency, straight up and down, 12 o'clock position, that's 120 hertz. And then here you have the AC balance, which is your cleaning action, and right there is 30%. That's typical, okay? All right, so let's jump over here. We're going to 2T, which means we're using the foot pedal, so we don't need to worry about this knob or this knob or that knob or this one. So any of these four knobs can be anywhere. They don't do anything in 2T mode, okay? So the only knob you have to worry about here is the welding current, okay? Now for the butt weld, the first weld we did in this video, I used 125 amps. So that's 1 amp per thou of thickness. We had roughly 125 thousandths wall on the tubing and on the bung, so 125, okay? For the fillet weld on the pipe to timing cover, I bumped this up to about 140, 145. I needed a little more heat for the fillet weld, okay? Now let's go over here. Pre-flow, I just had this straight up and down at 12 o'clock. Not sure how many seconds of pre-flow gas that is, but in any case, I just left it there. We don't care about this guy or this one or this one. This is all pulse settings. Pulse is off. And then here, post flow, I just had it right about 11 o'clock, and that's a few seconds of post to cool off the tungsten and prevent it from getting contaminated and whatnot. You don't need a whole lot of post flow on aluminum, but in any case, I had it just to keep the tungsten clean. And that's pretty much it. And then it's just a matter of welding. Now, at first, I had a number 8 gas lens cup on here because so I bought these gas lens stubby lenses because I thought they would make me weld better. Well, it turns out it didn't do anything, okay? So anyway, the number 8 was fine, but then in a tight area, I switched to, what is this, a number 5 standard cup that came with the machine just to get in the tight area that fillet weld. That's it. So nothing fancy there. I had a little bit of stick out there, about 15 CFH flow for gas, okay? And then as far as filler rod, for the fillet weld, I used 40-43, 3/30 seconds, because it seemed like it needed, you always need a little more filler material for fillets. And then for the butt weld, I used 16th filler material, and I used 53-56 because that's what I had. I mean, both of these filler materials seem sufficient for this job. Is one better than the other? I'm not sure. So look up a chart or something like that. I'm not too sure about that. That's just what I have. So that's it. I mean, that's pretty much it. And one thing I want to mention about the weld on the timing cover is I had a lot of contamination. So as I started to weld, I saw all this black junk come out of the metal of the timing cover. And that's because that timing cover was on the engine since 2005, so 15 plus years, and it was in contact with oil. So I think there was oil inside the metal. And I did my best. I baked it on my grill at 350 degrees for an hour, and I vapor blasted it, degreased it with acetone and whatnot, and I still had that junk come out. So what I would have done differently is my friend suggested that, hey, dunk or soak the part in acetone for like a day or two, and it'll pull all the oils out of that. So that's something I should have tried, but You know, it's a little late for that, isn't it? All right, so that's going to do it for this video. Make sure to check out the Prime Weld unboxing video here, and I'll leave a link to their website. It's a great machine, and I hope to get better as time goes on. All right, and that's the goal. You just got to practice.